So this is the next session. It's the session before the first break. And like Ruben mentioned, now we're looking into some of the benchmarking. So this is the first session about performance. And the question is always, how do we measure perceived remote end user experience? And Rex Analytics is one of the answers how we can do that. And Rex Analytics was developed within this community, within TeamRGE. And Kristin Griffin, she contributed a lot to the session that I will be presenting now for the next 20 minutes. And so she is also one of the creators of the Rex Analytics framework. So we created this company together, and so it's influenced a lot by the members of TeamRGE. So what's the idea? We all know that superior remote end user experience is important if you want to be successful with your line of business applications, for the reasons that we mentioned in earlier sessions, like that the standard applications like Office and the browsers, they take advantage of GPUs, for example, and we want to find out how massive the difference is if you're using a GPU versus not using a GPU. And Rex Analytics lets experience you what the changes to the application delivery, for example, with a GPU or without. How does it affect the end user experience? And GPUs is only one of the, we call it research areas in the Rex Analytics terminology. But you can see there are many more, like if you have different network conditions, if you're using different remoting protocols, if you're using different endpoint devices, different screen resolutions, storage solutions, something that Ruben mentioned in an earlier session. It's also what happens if you have noisy neighbors, high load in your environment, and in particular, what if you want to lift and shift your workloads to the cloud? So these are the things that we want to find out with Rex Analytics, and this is how we build it. So what is our methodology? It's a little bit different to other benchmarking tools, because most other benchmarking tools are only looking at performance counters that live in the back end, while we also take a look at the primary user endpoint. So between the primary user endpoint and the target session host, there's a remoting protocol. Now, if you look at both sides, the sender and the receiver, you can record the user experience that you see on the endpoint, and you can collect the telemetry data. As soon as you have that, you can bring that together. So the upper quadrants here, they show the videos, the screen recordings that were recorded on the left side with a GPU, on the right side without a GPU. And the lower quadrants, they show the telemetry data at the same time. So the data is correlated. And that is the secret sauce, that we have the correlated data both on the front end and the back end. Good. The question is, how do we build such an environment? How does the test workflow look like? First of all, we have to build the environment. That's something that we refer to as adding workloads and personas to a target environment. The next step is that we run the tests and we track the results. So we trigger and sync test runs and the secondary user loads if needed, and we collect the videos and the telemetry data. So as soon as we have the data, we feed it into an analyzer. And in the end, we can present the results. This is how it works. It's like a physics experiment. And you have to build the experiment, then you have to run the experiment, and then you have to analyze it. So let's start with the build phase. We have the endpoint device, we have the host system, we have a VM running on the host system, and we have some backend components like Active Directory, file servers, everything that is required in order to run a particular application. In our most cases, we only need an Active Directory, a domain controller. That's good enough for our most basic tests. Now, if you start a workload that we have installed previously, then the primary user sees this workload running in his session or her session. And this is exactly what this picture shows you. So the right side is happening in the frame buffer, while the left side, this is happening on a real screen, and there's a remoting protocol in between. And we are most interested in the left side. It's not that we want to see what's in the frame buffer. We want to see what's on the monitor. And we have different workloads. Each of them are typically between 45 and 120 seconds. The reason is that we want to be able to cover different graphics formats like OpenGL, HTML5, WebGL, and so on and so forth. We have DirectX, we have videos, we have GDI. We have 40 plus of these workloads. They're all representing an individual graphics format. So we can answer the question if a particular protocol is really performing well with OpenGL, because there is not one remoting protocol or a remoting solution that is good for all the graphics formats that are out there. So these are the workloads. Now, if we take those workloads and we stitch them together, we can add something that we call runbooks and personas. They are designed for secondary users. The secondary users, they are the noisy neighbors generating, well, background load. So we use chained workloads that create the secondary user load. The thing is that we have the individual workloads when we run those tests that only run for 45 to 120 seconds, and we record them with a frame grabber, while on the right side, the secondary users, they can run and they create workload background noise for 60 to 90 minutes. So if we have those users up and running in their sessions, then we can use the time, like the 60 to 90 minutes, to run 20 of those workloads, primary workloads, and record them under the conditions that there are 4 noisy neighbors, 9 noisy neighbors, or 15 or 16 noisy neighbors. So we can select how many noisy neighbors we want to introduce to the system and then see what it feels like for the primary user that represents myself, for example. I want to know what it feels like if I have the noisy neighbors on the same system. Now, to record everything, we need video capture that we connect to the client, and we record the videos. At the same time, we're collecting the telemetry data in the host system or in the VM that's running on the host system. Now, we put all this data into a repository. So we have the videos, we have still images like screenshots, we have the telemetry data in CSV format, we can have additional text information, and we can have documentation that shows us what the setup of the system was. Now, if we have all this information, the REX data, the videos, the telemetry data, the documentation of the hardware, and we can add an optional experts report and feed that all into a component that is called REX Analyzer. This is our workhorse when it comes to analyzing the technology. So how is REX Analyzer built? It took us a while to figure out a way to make the to make it consumable in an easy way, because we didn't want to give our customers or our fellows in the community, we didn't want to give them charts that are hard to understand and hard to interpret. So we decided that we want to have a 4-up video setup, which is kind of on steroids. And we start with a quadrant in the upper left corner. This is our pacemaker video. So this is a video stream that acts as the timer. And we add more videos or more data to this pacemaker video in the other quadrants. So there's quadrant 2 in the upper right corner, then quadrant 3 and 4. In most cases, we use quadrants 1 and 2 for videos and quadrants 3 and 4 for telemetry data. But this can be modified if you want to. It's only a matter of configuring that. So the only requirement is that there is a video in the quadrant number 1. Now we add playback control, so as soon as we start visualizing the data, which means showing the videos, running simultaneously, and feeding telemetry data into the analyzer that is synchronized with the videos, then we can play back all these things animated and visualize in a very easy manner what it means to the telemetry or to the resource consumption when certain things are happening on the screen. And now you see the red color and the blue color. In most cases, we compare things on the left side with things that are happening on the right side. So we are running exactly the same workload as a video in the left quadrant number 1, and we run it with a different setting in quadrant number 2, and we inject the telemetry data in quadrants 3 and 4, and then we have the results. Now you see in the lower right corner we have settings and edit, which allows us to modify the settings that we selected, or we can completely change the setup of what video we want to show and what telemetry data we want to assign to it. So this is what the edit mode looks like. So you see the path to the video or the path to the CSV file. We can populate the header with some info text. We can add an XML file that is a complete description of the installation. And you see there are these sliders in case the videos were not recorded in a synchronized way. We can use the sliders to move the video and the telemetry data forward by a second or two, so that the two sides, left and right, they run in a synchronized way so that it's easier to compare them. And the result looks like that. This is just a screenshot of a result that shows you the effect that I presented earlier at the beginning. It's exactly the same scenario where I have a GPU on the left side. It's an AMD S7150X2 using the RDP protocol in a Windows Server 2016 RDSH machine that is running on top of ESX. And so on the left side, it is ESX plus the RDSH 2016 without Horizon. And on the right side, it's also without Horizon, without anything. It's just a pure RDSH machine. But on the left side, it is with a GPU. And on the right side, it is without a GPU. All the other settings are exactly the same. And even if it's only a screenshot, you can see the effects. The CPU on the left side is very low. So that means that the CPU consumption stays very low when there is a GPU in place, while on the right side, the CPU is saturated. And just to give you an impression, those were 8 cores of a CPU. So it was a very, very powerful VM with a lot of memory. So you see that it is 32 gigs of memory. That the memory consumption is extremely low because it doesn't consume, almost doesn't consume any memory, but the CPU consumption is massive. And you also see the difference in the network because on the right side, obviously, it does not deliver any frames per second. Sometimes it just shows you a little spike that it delivers like 1 frame per second. For obvious reasons, the network consumption is very low because there is no frame that can be delivered because the CPU is saturated by rendering the graphics without the GPU. While on the left side, you can see that we have like 10, 12 frames per second. And so the network consumption goes up, but the CPU load is very low. That's something that can be seen easily by a screenshot. But later in my next session, you will see all these results in animation. So in summary, this is what the Rex framework that Kristin, Griffin, and I built. looks like. So again, you have the endpoint device, you have the host system, you have the video capture, you have the tracker that collects all the data, you have the secondary users that can optionally create background noise, and you have the analyzer component that is used for the visualization. This is it for now. So this is the session as a preparation for the session after the break. That's going to show you the best results that we have collected over the last 6 to 7 months. Yeah, it's the results that we collected in 2019. It's the top 3 use cases and results that we have collected that I will be showing in the upcoming session after the break.